Hi everyone, welcome to our Design Expo video. We are Supermileage Systems Enterprise from Michigan Technological University. Today, we will be going over a team introduction, an overview of our team, and team progress to date, before moving on to our senior design projects, including next-gen powertrain, suspension, driver interface, and lastly, dyno redesign. Then we will be discussing upcoming challenges for the team. Next, I will be showing you a video of our 2023 competition. This shows our vehicle crossing the finish line.
Supermileage Systems Enterprise is a student-run, multidisciplinary organization where we are interested in developing a hyper-efficient vehicle to promote sustainable transportation. And by doing this, we also compete with other top universities nationally. Historically, in the past, we competed at the SAE Supermileage Competition from 2006 to 2022. Unfortunately, that competition was discontinued last year. After that, we have switched to the Shell Ecothon Americas competition, which we also competed in from 2016 to 2017. Last year at the SAE Supermileage competition, we placed third overall as well as third in mileage with a total of 958 miles per gallon out of 13 total participating teams. The goals and projects for the 2022 and 2023 semester. For organizational goals, we wanted to maintain the productivity and engagement of the team, as well as maintaining the development of our new members, as we had a lot of those this year, and focus on internal business functions such as publicity and recruitment, and develop a new test plan in compliance with the Shell Eco Marathon competition. For the vehicle, we wanted to manufacture a new shell for the new competition, increase engine testing facilities for more accurate results, manufacture, implement, and test all critical components for the vehicle, as well as coordinate and align projects among all sub-teams and systems. And finally, we wanted to test the vehicle before the 2023 competition, then complete validation and revision of senior design projects.
So team progress to date is shown here. Most projects are already essentially complete, being that we have competed on April 15th at Shell Eco Marathon. Those projects that are still finishing up are basically completing final manufacturing and documentation for future reference. Shown here is our team budget split into the 4 major categories of team level purchases that support the entire team, and then those 3 subcategories based on our team subdivisions of body team, engine team, and electrical team. Moving on to our first senior design project was the next-gen powertrain project, whose goal was to design, manufacture, and test a new propulsion system for the Supermileage vehicle. Our final system decided on was a Honda GX35 engine with a fixed drivetrain. The major benefit of this system was reducing the weight from 36 pounds down to 11, and this 35cc engine is able to propel the vehicle with sufficient acceleration with the stock carburetor, and the final system will be tested and validated with our electric fuel injection system to compete in the future competitions.
Moving on to our next senior design project, that is the suspension senior design. The objective of this was to design and build a lightweight suspension system for the front axle of the vehicle. This is to prevent wear to the vehicle structures during testing, which has happened in the past. To achieve this objective, the goals were to research and evaluate different suspension designs, select a preferred design, as well as design a low-profile spring damper with independent compression and rebound. So completed work, a carbon fiber leaf spring suspension system was designed. This designed and manufactured a rotary damper for each spring with independent compression and rebound. Composite material properties for the springs were simulated, as well as FEA was used. 3-point bend testing on composite laminates for the springs was conducted to select the final laminate design. For the remainder of the 2023 semester, manufacturing and assembly of the spring mounts will be completed. The spring carbon fiber layups will also be completed. And then finally, assembly and testing the entire system in the vehicle.
The next senior design project is the driver controls interface senior design. And so the objectives for this project were to design and install new driver interface engine and communication controls, and then also to research and design a wireless engine data transmission system. So the goals for this project were to design the hands-free communication system, test and install it, and then design the data transmission system, and then write a manufacturing plan. So the current system has the hands-free communication system installed, and it is compatible with GMRS or ham radios, and the hand controls are integrated with the vehicle wire harness. Additionally, the manufacturing plan for the wireless data transmission system is complete. Future work requires obtaining a ham or GMRS radio license yearly for competition. And then we will need to reference wireless data transmission system manufacturing plan to purchase the system hardware and assemble and test the system.
All right, so moving on to the last senior design project is the dyno redesign. The project objective is to improve the SSE dyno test cell for safety, robustness, functionality, and process with forward-thinking design. Then goals include improvements of the engine mounting system, as the team is currently moving to a GX35, which is a different mounting system than our Junior 206 that we've used in the past. Increased functionality, usability of data acquisition system, improve electrical safety and organization, and lastly, enhance the fuel system. As you can see in the picture below, that is a graphic of our whole system running from one end to the other. Next, system solutions include engine mounting system to accommodate future engines, hardline fuel system with pressure regulator and fuel filter, comprehensive system documentation, and organized subsystem electrical enclosures. Future work includes integrate commercial dyno controller into test cell and fuel system validation testing. Upcoming challenges include recruitment and pass down knowledge, as many seniors are graduating, and getting ready for the spring 2024 Shell Eco Marathon competition, and improving the vehicle based on our results this year. Thank you for watching.